Assalamualaikum and good day to everyone. It is my pleasure to welcome all of you to the International Telecommunication Union Center of Excellence online training program on 5G implementation, practices and case study. This course is jointly organized by Wireless Communication Center, University Technology Malaysia, and International Telecommunication Union in collaboration with IEEE Malaysia Communication Society and Vehicular Technology Society Joint Chapter. My name is Nur Aisha Muhammad from UTM, and I am your session chair for today's program. Kindly be informed that this event will be recorded and will be shared to other participants in the ITU Academy. Okay, throughout this week, our distinguished speakers have thoroughly explained on the 5G implementation considerations, economic views of spectrum management, and a brief explanations of the spectrum sharing. So, as a continuation of the previous modules, today we have module 5 on network infrastructure sharing, which will be presented by Associate Professor Dr. Chi Yan Bruce Leow from UTM. Okay, for your information, this module will take approximately 45 minutes and 15 minutes for the Q&A sessions. All the participants are invited to post questions in the chat box throughout these sessions. Before we proceed, let me introduce to our speaker. Associate Professor Dr. Chi Bruce Leow is an academic staff at School of Electrical Engineering UTM and research fellow at Wireless Communication UTM. And currently, he's also a secretary at IMT and Future Network Working Group, a Malaysian Technical Standards Forum Berhad. He obtained his PhD in Wireless Communications from Imperial College London and Bachelor of Engineering in Computer Engineering, UTM. And his research interests includes non-orthogonal multiple access, drone communications, autonomous and connected vehicle communication for beyond 5G. Okay, without further ado, I would like to invite Dr. Bruce to deliver his presentation. Dr. Bruce, the floor is yours.
Okay, thank you, Dr. Aisha. Thank you for the intro. All right, so glad to see everyone again in this session. So what I'm going to do now basically to share the slide. Okay. All right. Okay. So you should be able to see my slides now, right? Okay, so right. So today we're going to continue the presentation. So yesterday we talked about the spectrum. So first we have the previous speaker, Mr. Amil, talking about the economic of spectrums. So how actually the bidding can be done, and then the licensing process as well. Then how much do you pay actually for the spectrum, right? Of course, that differs from country. All right, then second part, we have Dr. Marwan also talk about the sharing of the spectrum between 5G and also the existing 4G system. So now when we talk about in the case that I still remember the question from Mr. Amel yesterday, he did a quick poll, right? So whether is it what you call is it a good time to celebrate whenever operators has already secured a license to operate the 5G, okay, spectrum license, right? Of course, it depends, right, on the situation. So once the operator has already obtained the license, then the next thing that they will have to do basically is to deploy the network. So when we talk about network deployment, we talk about what is the best kind of practices in the industry in order to reduce the kind of capital expenditure and also the operating expenditures of rolling out this brand new 5G networks. Okay, so that is the purpose of this module, basically just to highlight the some of the industry practices involved in 5G deployment. So which we talk about here about the network infrastructure sharing. Right. So when we talk about sharing, then the first question is why do we want to share, right? So should we share the network with other operators or should we not? So what is the main motivation for sharing? All right. So then if we say we decide to share, so what kind of, which part of the network should we share? Is it just the tower or is it also include the base station or can it also include the core network? So which part of the network can be shared? So what are the benefit of sharing different part of the networks? Then the next question is who actually own the shared networks? So is it owned by kind of by a sharing basis between the operators, or is it owned by another party? So we will look at the different sharing ownership model also in this short module. And then we will look into some cases, okay, sharing cases in the Asia Pacific regions. So some of the sharing practices by some of the selected countries in Asia Pacific region. Okay, so let's start the first question. So why actually the industry now when we talk about 5G, so we're talking about sharing. Okay, the industry or the operators now tends to share their networks, but of course we need to know the motivation behind. So if you look at the graph on the left hand side, so this one is the survey or the survey from the McKinsey and Company. Okay, so basically to do a projection of the cost involved to roll out the 5G networks. Okay, so if you look at that projection, basically the what do you call very what do you call the minimum in terms of the assumption here, talking about, let's assume about 20% data growth. So in the next within the 5-year periods, you're going to invest at least 60% more, okay, compared to the current 4G networks. If you talk about if the data rate requirements even more, let's say go up to 50% data growth within 5 years periods, then you're going to see that the total cost of rolling out the 5G networks in order to accommodate the 50% data growth is going to be triple, okay, 3 times, as high as 3 times compared to the total cost of ownership when we are operating the 4G networks, okay? Right, of course, here in this result, of course, it's only calculating the total cost of ownership for the radio networks, which does not include the core network yet. Okay, so we can see generally to roll out the 5G network, it costs a lot of money. It's not cheap. So if you look at the second figure here, so it shows the also the in terms of the total cost of ownerships. Okay, comparing the pre-5G, so if you talk about 4G, existing 4G networks, which is 2018, right? And this is normalized result, so meaning that 100% is comparison to 4G networks. When we have that in 2018, the cost to own a 4G network, operate on 4G networks, compared to in 2025, if you would like to operate a 5G network in a standalone fashion, meaning that there's no sharing. Okay, so basically the operators will going to roll out their own networks, their own base station, their own core network. Okay, so in that case, how much the cost will be? So of course, from this kind of survey or this study, they found that it's at least like 80%, 86% more compared to the total cost of ownership for 4G networks. Okay, then if you do sharing, so they study if you do certain form of network sharing, so would it be beneficial in terms of the reducing the cost? So the result shows that by sharing, by performing a network sharing, especially focusing on not just the passive sharing, also including the active sharing, so you can actually drive the cost down, okay, to about 30%. So in this case, if you compare the share network, the cost to operate a share network compared to 4G, then it's just additional 57%. Compared to if you operate the standalone network, of course, the cost is more substantial here. Okay, so now it's established that, okay, now we have to share. The operator will consider the option to share because this will actually help them to reduce the capital expenditure and also the operating expenditures of rolling out when they're rolling out the 5G networks. Then if you look at the trend here, globally, we can see that there are more and more number of network sharings being practiced by the industry. So if you compare in the 3G timeline, 3G 2000, you can see very, very little. When it comes to 4G 2010, we have the 4G now. This has become a trend. And then 2020, remember, is the beginning of the 5G network. So as early as 2019, we already see numbers of commercial 5G networks available. So you can see that there are various forms of sharings, and then the number of shared networks actually increase across the years. Okay, so in 5G, definitely sharing is kind of one of the best practices in order to reduce the cost of operating the cost of what you call rolling out and also operate the 5G networks. So of course, when you look at the figures here, so this is a figure from GSMA. So we talked about GSMA before. Basically, it's an association from all the network equipment vendor and also the telco. So you can see there are different types of sharing, so which we will talk about in a moment. So depends on the types of sharing, then we can see that there is a rise in number. For example, we can see here tower co means that there's a tower company which operate the tower. The tower will be shared by multiple operators. So there's tower co, tower company, tower sharing. Okay. So in general, we have also passive sharing, maybe site sharing, including also the tower or the mast sharing as well. Then if you look at here, we have a new trend which is called the active sharing. So which we will talk about in a while. So basically involve sharing the radio equipment, okay? Radio equipment, sharing of the spectrum, and also could also include the scope of sharing the core network, okay? Then of course, we also have the roaming, national roaming, where the traffic from the operators is routed to another operators. So let's say the operator A does not have enough coverage. So when the user is in the area covered by operator B will forward the traffic to the operators A network. So this kind of, we call it the national roaming or domestic roaming. Okay. So various forms of sharings exist. Okay. So basically, the main motivation is of course, for operator is to cut down the costs. Okay. When they cut down the cost, of course, hopefully they'll get a better return of investment. Okay. And then also provide the operators the ability and the incentive to invest. So because now you don't need to invest too high in terms of the amount of investment, now can be pooled. The cost of building a new network can be pooled by multiple operators. Okay. Then of course for consumer, what are the advantages of the shared network for a consumer point of view? Of course, when the operators are sharing their networks, okay, so in that case, we will have a better network quality. So for example, if operator, they can complement each other in terms of sharing their network to improve the coverage. So at the end user side, of course, we will get a better signal in our mobile phone, right? Then the quality of service could improve. Then through that practice also, because the cost of operating network is now lower, now they can be translated to the consumer or to the user like you and me, right? So our mobile subscription cost will be cheaper, hopefully, okay? So that is the direct implication. When they have a lower cost here, then the consumer will directly benefit from this cost reduction. And of course, not to forget that it's also beneficial for smaller operators. So where those operators, they don't have extensive networks, so they can actually share the network with another major operator who has wider network coverage. So in that case, they can also offer a good network services to the user, even though they are small. So also apply to new operator. Let's say if there is any new operator in the area for 5G, so they haven't got any 4G network, they don't even have any 2G or 3G networks, they are brand new 5G operators. So in that case, through sharing, they can offer a good coverage and good network quality, even though they don't have a very extensive network infrastructure in that country. Okay, so if you want to know more, there's a very interesting paper, basically from the business school. So we study about this, whether to share or not to share, what are the benefit and impact of sharing to the consumer and also operator. So this is very good papers. I come up from this of the point from this working paper. Very good paper from the Oxford Martin Business School. Then next, okay, now we know we want to share. Then the next question will be, okay, which part of the network shall we share? All right, so basically there are two types of sharing. Okay, the first type is called the passive sharing. All right, so passive sharing reflect that the part of the network which is shared, basically they are passive element. Okay, passive element means that they are not involving in generating or processing the signals. Okay, so basically passive, for example, a tower, for example, the site. Okay, right. So for example, the power supply. Okay, and sometimes antenna as well. So all passive elements. Okay, so operation is easier. Okay, because the network elements, for example, your base station is separated. Okay, so the base station is not shared here. So only the structure here, the mast, the tower, the site, the power supply, or there's some fiber core which can be shared by the operators. Of course, the advantage, of course, saving, because instead of everyone building their own towers, now we share the same tower or share the same mast. Or we can also pool in terms of sharing the site, right? So we have a site, then we have a few operators sharing the rental. Okay, that also help to avoid the duplication. So we don't want to see so many, like here, right? In one rooftop, we can see, wow, there's a few antennas here. Okay, so each of the antenna here is actually owned by different operators, and they have their own mast as well. So that will be quite crowded, right? So if you can share, then it will avoid the duplication, and also reduce the visual pollution. So otherwise you will see in front of you, let's say in a city, there are many antennas, okay, base station, masts actually erected on top of the rooftop or even on the specific site. Okay, so that is the good thing of it. All right. And the second type of sharing is called the active sharing. So what is active sharing? So active sharing means that you are going to share the active elements in the networks which involve in the signal generation and processing. So those equipment includes the radio transceiver or the base station, okay, the backhauls networks, and also the core networks. All right, so these are the active element because they will generate the signal. So for example, base station is involved in generating the wireless signal and processing the signal coming from the users. Okay, and core network, of course, will process all the traffic IP packets coming from the base station. And the backhaul network basically is to connect between the base station and also the core network, which we also sometimes call it the transport network. Okay, so in terms of active sharing, there are a few types of models that are available for active sharing. So first you have the first one, we call it the multi-operator radio access network. Okay, multi-operator radio access network. So in this case, as the name suggests, so you're going to share the radio access network. So what is actually radio access network? Radio access network basically referring to the base station. Okay, so when you have one base station, you call it the base station. When you have a number of base stations, so this collection of base stations which connected together in a common network, we call it the radio access network. So which is related to the generation and processing of the wireless signal coming from your 5G, 4G, or even 3G, 2G existing base station. Okay, so this case is called the MORAN. So from this word, we'll call this a MORAN. So when we talk about MORAN, means that you're sharing the base station. Okay, sharing the radio access network or the base station. And then the spectrum used by the base station, of course, is not shared. Okay, so each operator, they have their own spectrum. Okay, they have a different channel. So operator 1, they have a frequency band dedicated for operator 1. Operator 2 will have the frequency band dedicated for operator 2. But they can actually share the base station or the radio access network. Okay, then, and there is another model called the multi-operator core network. Okay, multi-operator core network. So in this model, basically, the base station and also the spectrum are shared. Okay, so it means that we use the same base station. We also use the same frequency band. Okay, and this frequency, the same amount of bandwidth, the same channels are being shared by the multiple operators. So this is called the multi-operator core network. So the name is a bit confusing because what happened to the core network? So this multi-operator core network, so this is a term coined by the 3GPP, right? So in short, we call it MOCN, or in full, we call it multi-operator core network. So this name suggests that the core networks are not shared. Okay, so when we talk about multi-operator core networks, the core networks are not shared by the operator. So they have their own core network. So same like Moran also, the operators only share the base station, where they run their own core network. Okay, so there is a further form of sharing, which is called the core network sharing. Okay, so core network sharing refers to the case where we share everything, starting from the base station. We can also share the spectrum, and we also can share the core networks. So almost all of the network elements in the networks are shared, starting from your base station and including also your core network. Right, so this figure basically tries to summarize what I talked about just now in graphical form. So hopefully it gives you a better idea, actually, what are the differences between all this sharing model. Okay, so let's say we have operators like this, so passive sharing. So just now, the first part we'll talk about passive sharing. So passive sharing can be shared site sharing, right? We share the same site, we share the same tower. Okay, so if you can see, the site is shared or the tower is shared, but then they have their own base station, they have their own backhaul network, they have their own what do you call base station radio controller core network as well, and they use their own spectrum. So operator A and B, they have their own spectrum. So this is common practice. For example, in 4G, this is something common to share the site. Okay, then you can have also the next level of passive sharing, which you share the backhaul. So where the radio equipment, the core networks are all independent, and the spectrum are also independent. So these are considered the passive sharing. Okay. Then if you move to active sharing, which is what has become very popular in 5G networks, okay, which we will talk about later on during the case study. So the first form is called the Moran. Moran is where you share the base station. Okay, so you can share the site, share the base station, share the antenna. Okay, basically you share the whole base station in short. Okay, but you use your own spectrum. Operator A will have their own spectrum. Operator B will have their own spectrum. They have their own frequency band for operating their network. Okay, independently, so they don't share the spectrum. Okay, and they also have their own core network, so they don't share the core network. So they have their own core networks for operator A and B. So that's called Moran. So what about MOCN? MOCN is the case where we also share on top of base station sharing. So base station in 5G, you call it G Node B, right? G Node, next generation Node B, or the 5G base station. So that is shared, or the radio access network is shared. Sorry. The spectrum is also shared. So instead of having the spectrum to be split into two parts, one is for the user operator A. So let's say you have a 100 megahertz here in this channel. Let's say in this band, we call it, let's say example, 3.5 gigahertz band. You have 100 megahertz of bandwidth. So if you use Moran, then 50 megahertz go to operator A, another 50 go to operator B. Or it could be other combinations. This is just an example, right? So if you use MOCN, then you can share. So you have the access to whole 100 megahertz contiguous bandwidth, and which can be accessed by both the operator A and B, because now you are sharing. So of course, if you look at the case, if you have 50 megahertz, then your performance cannot be better compared to we have 100, right? 100, of course, the performance could be 2 times better compared to the case only you have 50, right? So in terms of capacity, in terms of band data rate that you can offer through the spectrum sharing will be much more substantial, especially if operators, they are sharing the same pool of bandwidth. So the user could have the access to a wider bandwidth, all right? But of course, you have to take note that for Morken, the core network is not being shared. So they run their own core network. Okay, operator A have their own core network, operator B have their own core network. Then the we call it the almost the full sharing here is to share everything. Okay, starting from your spectrum, your site, your base station, your core networks, everything is shared. So this is generally we call it the core network sharing. Okay. So of course, the degrees of cost saving depends on the level of network elements, amount of network elements that are being shared. So if you're able to share more, then theoretically you're going to save more. Theoretically, okay. All right. So if you just say passive, have passive sharing, you're going to achieve saving. But if you do passive and also active sharing at the same time, you're going to have more saving. Okay. Then, of course, when you share more, then it is more complex to manage. Okay, especially the case if you also share the core network, then the complexity also increase. Okay, so that's a trade-off. So how much do you want to share? So this is an example of visualization of the two popular one, which is called the Moran and Morken. So this is generally these two techniques, we call it the RAN sharing, radio access network sharing. So how to share the base station. Okay, so you can have Moran basically refer to you have operators. These two operator operates at different spectrum, different frequency band. Okay, frequency channel. Okay, so they have different frequency channel. F, you can see the frequency is different, right? Then they share the base station equipment. So the base station equipment share. All right, the core network, they have their own core network. So in terms of coverage, then these two operators, even though they share the same base station, they will have a different coverage, okay? Because they operate at the different frequency, right? Okay, they have different frequency channel. All right, so of course the coverage will be independent. Okay, and for Morken case, since they also share the spectrum, they use the same frequency band. Okay, same channel as well. All right, in that case, the coverage between these two operators are actually the same because they are sharing the spectrum. So the coverage is exactly the same. So this table try to compare between these two, what are the same, what are the different. Okay, so of course, core network, both are using independent one, and base station, both are shared. So only difference is that the spectrum for Moran is independent spectrum, while Morken is shared spectrum. And the coverage area, since you have an independent spectrum, then your coverage will be independent as well. Morken case, since they share the same spectrum, share the same frequency channel, then of course they're going to have the same coverage. Okay. So of course, it's important to highlight here that why core network is not shared, because that is actually one of the way operators want to differentiate their service. So if everything the same, then there's no difference if you choose operator 1 and 2 because they have the same coverage, the same quality of service, the same user experience, everything the same because they share everything, right? So in this case, RAN sharing is actually quite popular because we just share the radio access network, but we still have our own core network. So we're able to differentiate our service. Even though the coverage is the same, the user experience can be different. Okay, so that depends on the performance and then depends on the capability of the core network. All right, so this is the table just to compare between various forms of sharing. So in general, if you share more, then you save more money, okay, theoretically. Then, of course, you could also require some additional complexity here. For example, if you do Moran or Morken, so especially for Morken case, you're going to require the approval because you have to get the regulatory approval in order to use the whole spectrum, right? To share the spectrum. So normally this is regulated, right? Because if you involve the spectrum sharing, definitely regulatory process is required. Okay, complexity of operations. Okay, because you share you have to manage the base station, sharing of the base station. Okay, how do you want to share? How much bandwidth you allocate to this operator 1 and operator 2? Okay, who should it get equal, or should we get more on a custom ratio, or could it be dynamic being shared between operators? And requires agreement, long-term agreement. They call it the network sharing agreement. So same for the core network sharing as well. So it involves also sharing the spectrum. The complexity even more higher because you also share the core network. Okay, so the simplest form to share, of course, is passive sharing. You just share the space, or you can share the tower, or you can share the mast. Okay, in that case, this is the most straightforward. Okay, because the equipment wise is still independent. All right, so then next question is, okay, now okay, I know what part of the network can be shared and how we can share it. Either depends on which level of sharing you want to go for. Then the next question is, who own the share network? Okay, who own the share network? So one of the model here is called the neutral host. Okay, this is also what do you call popular model. Okay, so neutral host basically involve a third-party provider, okay, which will construct and own the network infrastructure equipment. All the equipment is owned by this provider, wholesale provider, and then it will offer the access to the network infrastructure, okay, network bandwidth resources to the operators in a wholesale basis, okay, and it should be neutral, so it's not kind of only sell to operator 1. Any operator, I can sell my what do you call? I can list the network resources to all the operators, so it should be neutral. So you're not going to be biased or only going to sell to operator 1. I'm not going to sell to operator 2. No. So when you talk about neutral host, you talk about neutrality. So they provide the infra. So infra then can be accessed by all the operators. So not only operators, it could be the case where there are some private enterprises, they want to operate their own private network. Then in this case, you can also what do you call? Buy this wholesale access from the neutral host to use part of their network. Okay, so basically this provide opportunity for the operator to share the neutral host equipment and also the spectrum. Okay, network equipment and also the spectrum. And of course, operator in that case, they don't need to pay for the equipment, right, or the infrastructure, network equipment. They because the spectrum is held by the neutral host, so then is licensed to the neutral host as well. So then that helps to actually reduce the cost. Okay, when the cost involved in rolling out the network is reduced, then you improve the efficiency. Then the deployment could be faster, hopefully. Okay, and then of course reduce the impact to the environment because you want to avoid duplication. You want to avoid redundant equipment, right? So you want to optimize on the use of the network equipment, network infrastructure in order to provide a good level of coverage and services. Okay, and and the capacity as well. So the conventional model looks like this. So you have a mobile network operator. MNO is a mobile network operator. So each operator, they have their own equipment. Okay, one site you can have multiple operator. Okay, at the same site. So it's called duplication, right? Because you have equipment here, also another operator also have the equipment there. So many equipment at the same site, because this site is a popular site. Of course, many operators are going to set up their equipment there, their network equipment and the infrastructure there. Okay, so but we talk about neutral host model, then in that area, then we only set up single infrastructure, network infrastructure, then which is shared by multiple operators. So this model is popular, for example, in a public area like airport, hospital, okay, or this public area. So in those area, neutral host is kind of popular for. So the wholesaler equipment or network provider will set up the network, and then service provider will actually provide the network services to the end user. Okay, so if you look at here, that is referring to this case. So basically, you have operators, okay, using the infrastructure provided by neutral host. So in that case, the network is owned by neutral host. Okay, so this is called the third-party service provider. Of course, you can have other models as well. So you could have the JV or the joint venture model. So for example, this operator A and B, they sign a joint venture agreement. So the infrastructure is financed jointly by operator A and B. So they build this together. They pay and then they construct this together. So it's called a joint venture lah. So the equipment or the networks infrastructure is owned jointly by these two parties. It could be also the mutual service provisioning. So meaning that at certain area, operator A will actually share the equipment with operator B. So similarly, at certain area, operator B could share the equipment, so could share the infrastructure to operator A. So this is mutual. Okay. So of course, this operator A network is owned by operator A. This operator B network is owned exclusive by operator B. But then since we want to complement each other, because in that area, maybe operator A has more base stations, better coverage. In another area, operator B has better coverage. Then they complement each other by using this mutual service provisioning. It could be also the unilateral service provisioning. So unilateral means that, okay, so the infra is owned by operator A, then operator B could be a smaller player. Okay, they don't have so much of infra. Okay, they will just what do you call rent or share the existing infra with the operator A. Okay, so that is a different sharing model. So underneath the ownership also, there is one model which we heard since day one, right? We heard people talking about single wholesale network. Okay, so I think day one we talk about this, right? Many of you know what is single wholesale network. So for some of you, maybe something new to you. Let me just give you a brief definition. What is single wholesale network? Okay, single wholesale network basically is a single national network. Okay, so the word here important is single. So wholesale network is actually similar concept like the neutral host. So concept is similar like neutral host. The only difference is that you only have one neutral host in the country lah. So in the case that you only have a single infra provider, so they will actually in charge of building and rolling out the 5G infrastructure. Okay, so this is called the single national network. So you're not allowed to have a second network. Okay, so one country only got one network. Okay, so of course the idea is to avoid duplication, avoid too much of redundant network infrastructure, maximize the spectrum utilization. So let's say if you have 100 megahertz, you have 5 operator. Each operator, to be fair, then get given a 20 megahertz. So 20 megahertz is too small for 5G, right? To realize the potential of 5G, to get the gigabit performance, you need at least 100 megahertz, as we talked about before. Then by doing this, then you can have the whole 100 megahertz being shared with all the operators. So being able to access to 100 megahertz of bandwidth at least, then give you a good kind of margin to offer good kind of differentiated service compared to 4G. Otherwise, if you only have 20 megahertz, you can't do much compared to 4G, right? Then of course, reduce the capex. So you don't need to everybody, all the operator go and build their own networks. Now we can have this single wholesale network provider. They will build the networks, and the cost will be shared because they will have the agreement, the sharing agreement, okay, with all the operators, which will provide the services to the end user. So this single wholesale network only active in wholesale market. So meaning that they will not sell the network resources to the user lah. So in this case, wholesale, they sell the whole network resources, the access to the 5G network to the operator. Then operator will provide that service to the user. Okay, so this is called the third party somehow, third party provider. And normally it's a government mandated, because the only way to control, to make it a single wholesale network, government has to mandate this network. So meaning that they have to make the policy saying that, okay, we only allow a single network, single 5G network to build in this country. Okay, and of course the performance is regulated as well. And important to highlight here, the spectrum is held by this single wholesale network provider. Okay, they will be given the spectrum. So operator is not given the spectrum. Operator will just lease the network from the single wholesale network provider. Okay, so of course, when you do that, then you can do Morken, because Morken require you to share the spectrum. So in this case, because the spectrum is basically, you only got the single licensee for this spectrum. Of course, they use the whole spectrum. Okay, so it can allow for Morken, or even can allow for core network sharing as well. So in Malaysia,
interruption, you have another 10 minutes.
Okay, about to finish already almost. Okay, so in Malaysia, we have this model in place, single wholesale network. So we have a company known as the Digital National Berhad, which will build this network. Okay, they are already building this network. So currently available in Putrajaya, Cyberjaya, selected area. Not all the Putrajaya you will get the coverage. Selected area, okay, Cyberjaya, Kuala Lumpur, JB, and according to the report, by end of this month, it will be available in Penang. So for example, if you have Penang, then you have a 5G phone. So I think at certain part of Penang, starting end of this month, you should get the 5G coverage. Okay, so of course, they have planned to provide a 80% coverage in populated area by 2024. Right, so this is the model used in Malaysia. Okay, that's why you heard about it since the beginning of the day, right? Single wholesale network. So what is single wholesale network? Is it good or is it not good? Of course, there's no clear answer until now, because not many country has followed this model. Okay, so this is kind of new. Okay, in the case of, we don't have many data whether how this could be implemented, right? How this could be successful. So compared to conventional way, we have a network competition. Network competition means that depends on the market, depends on the operator, so they will build their own networks. So if you talk about single wholesale network, the wholesale provider will build the network. Okay, so of course they have a pro and cons each of this. If you go for traditional one, is based on network competition. Okay, we call it the competition network. All right, so they will build, depends on the demand. Okay, whenever the demand is, then there will be the network. So there's a downside, because operator will not be willing to deploy the 5G network at the rural area, because there's no user there. Then there's because the market, the user population there is very small, right? They have a less motivation to deploy their network there. But for single wholesale network, for example, is regulated by government, so they already set the policy. Okay, you have to cover not only the rural area, not only the urban area, you have to also cover the rural area. Okay, so there are pro and cons, of course. Currently, the mainstream, of course, using this model, so it's market driven. So Malaysia, we are using this model, single wholesale network. So of course, there are risks also involved, as all the project also, we got the risk, right? So could be the risk in terms of negotiation. So how do we come up with the agreement, right? Because you have so many people going to share it, then are they agreeing to the terms and conditions? Are they happy or not? They'll become the stakeholder. Then how is it? Investment and funding risk, because this one require all the operator to sign up, right? Regulatory risk, lack of incentive to invest. So this one could be the case. Let's say if you have this kind of single wholesale network, because there's no competition, because you are the one who built the network. So there's no one who will build a better network than you, because you are the only person who built the network. So that could be a competition issue, because there's no competition means that you might be less motivated to optimize your network or even to improve your network, because you are the only one. There's no one can compare to me. However good or however not good, this is a network. Of course, now the government, of course, have to step in to regulate the quality of service. So they have to make sure that the single wholesale network provider is able to meet the quality of service requirement. Of course, they also risk of failure. Let's say there's all of this is not done right, then the project can fail, because as happened historically in several countries, especially the less developed countries. So they use this model, and many of them actually not successful. Okay, so let's look at the case study. So we have a few minutes here to look at the case study. So network sharing is kind of common throughout the world. Okay, so let's look at in Europe. Europe basically is quite common to have network sharing. So network sharing here is not just within the certain geographic areas. So we are talking about national, the whole nation, or even regional. Regional means across Europe. So this is a practice in Europe. So if you compare to 4G or previous technology, right? So number of sharing agreement in Europe was 5, but now if you talk about 5G, it doubles to 10. So there are 10 national and regional network sharing agreement. Then if you look at the case here, equal number for Moran, equal number for Morgan. So they're going to share the base station for sure. They're not going to share their core network for sure. So some of them actually share the spectrum as well. Okay, so it's a big market because European population, it can cover 200 million subscriber. Okay, so other part of the world. So we have some summary here for some of the Asia Pacific countries. For example, Australia, Telstra, TPG Telecom, they have the Morgan sharing. Okay, sharing, they have an agreement to share the 4G and 5G spectrum. Okay, so basically, what do you call, the TPG will gain the network access for Telstra because TPG has less in certain area there has less number of base stations, so the coverage might not be good. So when they sign this sharing agreement, so Telstra will be able to share their network equipment, the base station with this TPG. Okay, all right. Then China also very common nowadays. For example, China Telecom and China Unicom, they have the Morgan sharing. So they have this, what we call the network sharing and co-construction model. So the share also, they jointly build the network. Okay, so at 3.5 gigahertz with 200 megahertz of bandwidth. Okay, share. Okay, and China Broadcasting Network and China Mobile. So China Broadcasting Network, of course, traditionally they do broadcasting, they do TV. But in 5G, they were awarded the license to operate the 700 megahertz 5G network. So in this 700, you know, low frequency below 1 gigahertz, the coverage is extremely good. So in this CBN network, China's Broadcast Network, they share their network with China Mobile because China Mobile is one of the major operator. They have extensive 4G, 5G networks in China, right? So in this case, the new entry into the 5G service, what do you call, 5G networks here, CBN, then they can tap into the extensive network owned by the existing major network player. Then the China Mobile also get some benefit because when they have the access to 700 megahertz, so they can offer very, very good coverage as well. They can also offer IoT services as well at this 700 megahertz, which has excellent coverage. South Korea as well, if you look at here, South Korea, we have the operators, major operator, SK Telecom, KT, LGU+, which they share their networks in remote coastal area, all the island, all this Jeju Island, okay, all this famous island, coastal area and the rural area, okay, coastal area, rural area, where in that area, of course, the number of subscribers, they're not so many, okay, so then it makes sense, of course, to share networks in those areas. Singapore, M1 and StarHub, they have a joint venture, okay, to invest and build the 5G standalone networks at 3.5 gigahertz mid-band. Taiwan, APT and FET, the operators, okay, they also use the network sharing, okay, and to deliver at the mid-band 3.5 gigahertz. So NSA is a network service agreement, basically. So Japan, actually, the case quite similar like the Korea, okay. Korea basically in the urban area, they don't share. In the urban area, each operator, they have their own networks, okay. While in the rural area, they will share. So similar like Japan, for example, KDDI and SoftBank. So in the rural area, they make use of the Moran. Moran means they share the base station, but not sharing the spectrum. Okay, so that happened in Japan. So in other words, sharing is somehow very common in 5G, especially because 5G has inherently technology known as the network slicing. So by having the ability to slice the network resource logically, okay, using the network functions, then it is kind of convenient to do the active sharing. So that's why what we see here, there are more and more active sharings in the 5G era, okay, and come in different form. Of course, the more popular ones are Morgan and also Moran. So core network, of course, could be shared, but operators mainly they don't actually subscribe to this networks whole network sharing because they still want to maintain certain level of independence, right? So that they can offer some differentiation, okay, between services provided by operator 1 and 2 lah. So otherwise, if you share everything, so network performance is also the same, user experience also the same. So you can't actually differentiate your services. So that's why I think many operators now they opt for the radio access network sharing, but still maintain their own core network. Right. So with that, I summarized already the session. So maybe the next we can open for Q&A.
Okay, thank you very much, Dr. Bruce, for very detailed explanations and insightful information. With that, we are now open the floor for the Q&A session. For all the participants, you can unmute your microphone if you want to directly ask the questions. We also have several questions from the participants. Let me share my screen first. Okay. Okay, for the first questions, is there any country or operator have standalone network for the time being, I guess?
Okay, so so the meaning of standalone here, if I try to interpret, is it talking about 5G standalone deployment? So meaning that you're going to deploy a brand new base station and brand new 5G core network. Okay, so of course, yeah, country, for example, like Korea, they started with a non-standalone network. Okay, then later on, they have also the standalone 5G networks. Okay, so if you talk about the definition of standalone, in the case that, so there are different definitions. So I try to understand here. Are you talking about the share? So is there any country operator have standalone means non-share networks? So there's, yes, of course, some country they will have prefer not to share. So it's going to be what you call going to happen, right? For example, as I mentioned just now, in Korea and Japan, in urban area they don't share the network. No, there's no any active network sharing we'll talk about. Okay, they could share the tower, they could share the site. Okay, that's passive. But when talk about active network sharing, in those area, country, Japan, Korea, they have their own network, radio access network, and also core network. But then sharing could come in, we call it the regional, I mean, or location-based sharing, or even selected area. So not necessarily the whole country you have to share all the whole network. Right? You can select which area you want to share. You want to share in urban area, or you want to share in rural area, which rural area. So it's up to the operators in their network sharing agreement. They will define the scope of sharing, which part of the network you should share, at where we should share it. So this is basically what happened.
Okay, thank you for the answer, Dr. Bruce. For the second question, does the national roaming needs universal SIM cards? As of today, we know that for different operator service require different mobile SIM cards. And if that case, does the current type of mobile phone itself needs any improvement to operate?
Actually, currently, like even 4G, remember we have mobile virtual network operator. So mobile virtual network operator, they don't own any network infrastructure. They are just virtual. So basically they buy the network access from the service provider. Okay, so for those kind of situation, you refer to national roaming. So in this national roaming, they enable services like virtual network operator and so on. Of course, it also good for operator who has less extensive network to tap on the resources of the more established network provider. So currently the technology is there. You don't need to change SIM card. It's the same SIM card, right? They can use the SIM card, same SIM card. Okay, so the traffic will be just, for example, you have two operators. So operator A want to use operator B networks. So operator B, upon receive this traffic, will actually forward that to route that to the operators A network. Okay, so this one can be done using the existing SIM.
Okay, all right. For the third question, can the passive and active network sharing be done together?
Definitely. So passive is the basic lah. So basic, at least passive now is the kind of the basic kind of sharing that we can have. So at least to share the site, share the tower, or share the mast. Okay, so that's a basic. So when you talk about active sharing, means that it also includes the scope of passive. That means that when you share the base station, meaning also you're going to share the base station tower, or you also be going to be co-located in the same area. Okay, so you can see like level lah. So level 1, of course, start with passive. Then if you're happy, then you go for level 2, active. So active means that you can do what passive can done. Passive sharing can do. You also get additional benefit from active sharing.
Okay, for the third question, he asking about the data security. So when the network is shared, does it mean that the operator can see or access other operator data?
Okay, data of course is encrypted, so any operators should not be able to gain access. Of course, your data is delivered in packets, right? So by default, it is kind of encrypted. So you just see the traffic, but then you cannot decrypt the packets because it's encrypted. Okay, so data is encrypted. So then there's kind of a bunch of security mechanism, authentication mechanism happening in the networks. So even though they share the network, but doesn't mean that they will see your data. So just like now you're doing a banking. So banking you use online. Hey, can Google see my password or not? So of course they have encryption going on. So you type in your password, it's fully encrypted, right? So only the bank can see your password. So the browser cannot see your password. The Unify TM cannot see your password. They can see the traffic, but they can see the packet, but they cannot understand the content.
Okay, the next question, what type of complexity are we looking at when sharing network?
Okay, complexity depends on the level. If you passive sharing as the lowest complexity, active sharing, if you share up to the core network, if you share everything, then the complexity will be there because you want to also define how do you want to share, right? Let's say you have base station. I'm going to share the resources 100 megahertz using Morken. Then in your network sharing agreement, then you have defined, okay, how do you want to share this? Is it going to be a quota, let's say 100 megahertz, right? At most, each of the operator can be using only 75. Or you say no quota, means that depends on traffic. If the traffic is busy, I can allow this operator to use 90 megahertz. Another operator then depends on the agreement. And then, so this basically is another level of complexity. So let's say you decided to share, then how you want to partition the resources, right? Either it's a static partition or it's going to be a dynamic kind of time changing on demand kind of partition, then that is another level of complexity.
Okay. The next question may be correlated with the previous questions. Maybe Dr. Bruce can explain about the billing process when they share the core network.
When they share core network, okay. So of course the billing, they have it could be they have a billing system, their own billing system. Okay, so if they share, then normally they have wholesale access. So it means that let's say how many GB, then how much you charge. Okay, based on the data, because now it's more packet network, right? So it's based on amount of data, and also based on the quality of service. Okay, so so that is the depending on the agreement, whether how they want to sell, how much it costs per bit, okay, of data that you use in this share network. So how much should we pay you?
Okay. Okay, for the next question, maybe Dr. Bruce can briefly explain the term site inside sharing. Which elements of the infrastructure is indicating it?
Oh, site basically is the location. For example, you want to set up a base station tower, right? You need a land, right? The land to erect the tower, and the land to also put the equipment, right? Okay, so that is considered the site. Generally, you call it the site. Site means the location. You share the location. So if you talk about site sharing, meaning that you could have two base station tower, but next to each other. Because they are located at the same site, but they are not sharing the same tower. So that could be also site sharing. So over on the rooftop as well, you can have the same rooftop, right? But then they don't share the mast or the antenna structure. Okay, they have their independent structure, but you put in on the same rooftop. So that's called the site sharing.
Okay. Okay, we have two questions on Mokan here. How the operator handle their user handshaking, and in the case of non-compliant, how it will be handled.
Handshaking, we talk about signaling, right? So this is done, what do you call? By the 5G core networks, okay? So their core network will actually do the handshaking process. So how, again, this is a complex question. So you can go into a complexity of telling you what kind of signaling involved, okay? So that basically involves the exchange of the control signal between the user and also the core network, okay? So in that case, in Mokan, they have their own independent core network. So it means from the base station, the control signal now will be routed to the respective core network server, okay?
Okay, for the next question, won't this sharing of spectrum between networks be prone to interference? It's about interference issue.
Okay. So so not really. So if you talk about sharing of spectrum, in the case that you will use the same spectrum, so same spectrum means that no interference. Okay. Because you're basically essentially just using the same spectrum, so there shouldn't be any interference lah.
Okay. The next question, which sharing model currently being adopted for 5G deployment in Malaysia?
Okay, 5G deployment is Mokan, okay, because spectrum is shared, radio access network is shared, but core network is not shared. Okay, and the ownership model is called the single wholesale network.
Okay, we have another questions. Would there any network interference between the operator when using Moran since it uses different spectrum on the same site antenna? I think this one is the same as number 10, right? Maybe Dr. Bruce want to elaborate more.
Okay, so if you use a different channel, also no problem because there will be guard band. There will be guard subcarrier between the channel. So let's say operator 1 channel 1, operator 2 channel 2, there will be a guard subcarrier to protect the base station or the user from the interference. Okay, so that basically shouldn't be any issue lah.
Okay, while core network sharing, if the core network crashes, what is the solution, or it is considered to be a virtual core?
Network sharing if the core network crashes. Okay, you remember core network is kind of nowadays they use the virtualization, right? So core network no longer is one equipment. It's kind of a array of it's kind of a server lah. Okay, so you have parallel computation resources. Okay, so then of course they have some redundancy as well. So by default, network should not crash. Core network should not crash because you have a multi-level of redundancy. So of course, currently is virtualized. I think the industry 5G, of course, we use network functional virtualization in the 5G core. So it's considered a virtualized core. So this is one of the important kind of improvement since 4G people already started to use the virtual core. Then 5G is going to be something which is common.
Okay, Dr. Bruce, we still have many questions here, but maybe due to the limited time, maybe this is the last questions. For core network sharing, how to determine the quality of service since end-to-end is being shared?
Okay, so core network sharing quality of service basically is measuring in the end-to-end as well, because QoS you can measure in the network, right? For example, data rate. So what's your data rate you can achieve, average data rate, and then what is your latency and all these things. So those are measured, can measure in the end-to-end from the core to the user equipment side. Okay, so then it can be measured just like a user case, even though it's being shared. But the problem, if you share the core network, if you're operator A and operator B, right, since you're running on the same core network, then the kind of differentiation you can have is actually very limited, because everything seems the same. So coverage the same, then the network capability is the same. So you can't do anything different compared to another operator who share the same core network. So that is the one of the issue okay, of the core network sharing, because it limits the operator to differentiate their service. So their service will look like the same. If you go for operator A, today you're not operator with operator A. Tomorrow you switch to operator B, same, because they're running on same core network, same base station, same coverage. Okay, everything same. So there's no way you can get a different service, because it's running on the same, everything on the same network, right? So then of course, when that happens, then in this case 5G, you can address the issue by using the network slicing. So let's say if everything is the same, but then the slice has a different kind of configuration. So maybe the operator one have a better, more kind of capable slice, okay, which can serve their user. Okay, then they will be able to differentiate their service. Otherwise, it will be almost identical.
Okay. I would like to apologize to all participants that we cannot address all the questions due to the time constraint. However, all the participants, you can post your question in the ITU forum, and our speakers, Dr. Bruce maybe, and the committee will address the question accordingly after this. Okay, with that, thank you very much, Dr. Bruce.
Right, thank you.
Okay.